Hello all and welcome to today's Markham interview webinar on the challenges of marine concrete. I'm Charles Curry, based in the Napier NZ office, currently on my last day of working from home due to NZ lockdowns. Today I'm going to be interviewing Doug Hamlin, our R&D manager in the Markham Infrastructure and Industry Department. Doug, would you like to introduce yourself? You're on mute.
Sorry, I thought I would have got used to that by now. Yeah, likewise, I'm just coming out of, we're obviously coming out of lockdowns in regional New Zealand. I actually managed to make it back to the office today, so which is a nice change. But yeah, like Charles says, work in the research, development, technical side. I also work on infrastructure projects, so right from design specifications, that sort of thing, to looking at older structures, ways we can extend their service life. Been with Markham just over 10 years, so yeah, had some good experiences along the way, and testing projects, things I've worked on. So yeah, back to you, Charles.
Awesome, that's great. So today's learning outcomes for this session are: what are the challenges faced by marine concrete and what can be done to meet these challenges in both new and existing concrete? And are there any other structures for which this is also relevant? The session is approximately 15 minutes long, and at the end we're going to be opening the floor to questions. So please use the Q&A button at the bottom, toolbar at the bottom of your screen, and put questions on as we go through. If what we don't cover during the interview, we'll address our Q&A session at the very end. Right, let's kick into it. Doug, can you give us a quick overview of the topic, and what are the challenges of marine concrete? Give us some context here too.
Yeah, sure thing. Yeah, so I guess firstly, let's start with a description or explanation of what a marine environment is. Now, obviously, the differing code standards explain it slightly differently, but in general terms, a coastal environment is considered either on the shoreline in the water or up to 1 kilometre from the shoreline. And then there's what they call a near coastal environment, which is up to 50 kilometres from the coastline. So that's basically where it's recognised as a risk of mainly chloride attack from the saltwater can occur either by physically, wetting, drying, or from airborne chlorides. Obviously, the highest concern areas are in the, not actually in the water, but in that splash zone where you've got variable moisture levels. You get that wet-dry cycling with tide changes, that type of thing, which is very, very harsh on concrete. That wet-dry cycle. And then obviously within a marine environment with the seawater, there's contaminants in the seawater. Obviously, mainly the chlorides, and these contaminants get into the concrete, attack the reinforcing steel and threaten its integrity, causing corrosion. And unfortunately, this damage is not a gradual process. So once it kicks off in the concrete, once the rebar starts corroding, it's not something that just slowly manifests over a number of years. It actually ramps up really quickly and accelerates, gets expensive really quickly. So that's the attack side of things. There's also the operational challenges as well. So if you think about a wharf structure, it's got traffic on it, whether that's vehicle, pedestrian, it's subject to loading. And there's also, when ships tie up, that type of thing, other marine vessels, they're always different stresses and loads caused by this. And, obviously the structures are designed to cope with these loads and for, what they're their purpose, but obviously over time there's the things like fatigue and that gradually just wears the structure down, I guess, and subjects it to more of that attack. But yeah, does that make sense, Charles?
Yeah, it does. It sounds terrible. Must be quite an expensive process to repair and replace these structures too. So what can be done about it?
Yeah, it is. It is expensive, and it's a bit of a sliding scale there as well. So the further down the damage cycle or deterioration cycle you get, there is obviously a higher associated cost. It's obviously that it's fairly basic, but we do really need to understand that concrete itself, while it's a very universal material, it's a great building material. It does have one major flaw, and that's that it does let moisture. It is a porous material and it lets moisture ingress and move through it, move out of it, and around it. And what happens is that moisture by itself may not be a problem, but it does become a problem when it carries contaminants and things to the reinforcing steel, which attack the natural protection layer around the reinforcing and causes that corrosion cycle. Now, obviously, there's ways to measure and see where that cycle's at. The very best is to be taking regular condition assessments, so you can pick up things like the chloride levels or other non-destructive testing, give you an idea of where that corrosion phase is at, what condition the rebar's in. And then there's obviously visual signs that start to occur, like cracking of the concrete. So as the rebar starts expanding, it puts pressure on the concrete around it and cracks it. And this eventually, as it gets worse and worse, leads to spalling, and you get exposed rebar. Now, what's really at the crux of this issue is that moisture movement, and we really need to immobilise that moisture. And that's a well-accepted fact. Every engineer designs concrete to be, as dense as possible, as durable as possible to protect against this. But there is still that nano scale or nano pathways, if you like, that moisture and contaminants flow down. So immobilise that moisture and stop those internal reactions of that corrosion from happening. So basically, we're robbing that process of one of its main ingredients. With that, as you can see on the screen there, we work with colloidal silica hydrogel technology. So this is, in essence, it's either added into the concrete or spray applied, and it reacts with the alkalis, and in the main, it's calcium hydroxides in the concrete pores and porosities, and forms a hydrogel, which stops that moisture migration and essentially waterproofs the concrete. And along with that, waterproofing the concrete, you stop those contaminants from being able to ingress the concrete. Now, this is much like the original cement hydration reaction when concrete's actually manufactured. So it forms a calcium silica hydrogel. A bit of a tongue twister there, but it is permanent. So once that's formed, you can't reverse that reaction, and it is there for the life of that structure. Is that making sense, Charles?
Yeah, it's good. Sounds a bit more positive to me. Is this in the context of remediating existing structures? Is that right?
Yeah. So typically that's where we get involved. So that's obviously either when someone's, been taking regular condition assessments and realised that there's need for preventative, proactive maintenance. If you're just starting into that corrosion cycle, and then there's obviously down the track when might get some minor cracking start to appear, or even after repairs have been conducted, and the asset owner needs to keep that structure in that same condition as it currently is, to get the best service life. So that's in the main. We are talking about existing structures, but it's also very relevant to new concrete. Obviously, if you can start right from day one, right from the ready mix plant, so to speak, and stop that concrete being subject to attack by or that reinforcing steel, I should say, being subject to attack from chlorides right from day one, it gives you the best asset life or best service life from the concrete. And there's a couple of ways of doing this, either into the ready mix concrete itself at the batching plant as an admixture, or spray applied soon after to the concrete. So yeah.
Very good. Yep. Sounds like it would be more relevant to more than just existing marine structures. Is that right?
Yeah, it is. Yeah, obviously we're focusing on marine structures today. They are a fairly common, concrete deterioration is very common in these structures. Basically, I mean, it all comes back to the chloride in the seawater, as we've mentioned. It is generally where it's most commonly associated with concrete corrosion. But there is other structure types for sure. So things like bridges over, tidal inlets, waterways, that type of thing, they can be subject to it as well. And then, even a eroding bridge structure in a high volume traffic environment, where we've got a lot of exhaust fumes, that type of thing, you can get increased carbonation, that's formed from the carbon dioxide and moisture. When that mixes, forms an acid and starts eating away at the concrete. And then there's things like varying levels of acid attack. So obviously soft water and potable water structures, that type of thing. And they obviously have a higher acid attack in sewer environments. So yeah, there's a wide range of structures that I guess they're subject to the same attack mechanisms because that moisture's pulling the contaminants into the concrete and degrading it. But yeah, as I mentioned, marine is a common one, and yeah, generally deemed as a higher risk area.
Yeah, very good. So with these structures being in quite sensitive environments such as sea life and waterways and so on, is the treatment safe to use, and is there a significant need to contain overspray, for example?
Yeah, good point. That's very valid concern. And with these colloidal silica hydrogels that we work with, they are a nil VOC product. So they're water-based. They don't have any volatile organic compounds in them. So yeah, overspray, that type of thing, when you're spraying over waterways, then for one, they're not harmful for the environment or for marine life. And most importantly, they're not harmful for our installers putting them in, or whoever may be spraying the treatments on. And another thing to bear in mind is we're not actually introducing anything that's not naturally found in concrete. So, the main binder of concrete is calcium silicate hydrate. We're putting more silica into the concrete essentially to form more of that calcium silicate hydrate. So we're really putting more of the good things into concrete. We're not putting something that's foreign or into the concrete. So yeah.
Yeah, brilliant. So I guess the other thing is how long it comes up regularly. Like, how long does it last, and does it need to be reapplied frequently? Along with that, what sort of warranties does it carry?
Yeah, awesome. Good question. So if we just go back a little bit to thinking about the reaction once that colloidal silica reacts with the alkalis in the concrete, it forms that hydrogel, that calcium silicate hydrate that can't be reversed. So it becomes part of the concrete itself. So in that essence, it doesn't need reapplication. So once a structure is treated, there's no benefit from a reapplication, with the exception of a very highly acidic environment where it may be wise to reapply the treatment just to boost that surface resistance. But yeah, in short, it is a one-time treatment, and with that we offer the project-specific warranties that are performance-based. So that's tied to either chloride levels in the concrete or permeability, of the concrete structure. And with that is based We are very project specific, both as individuals and as a company, and we consider every project on its own merits. So that's the environment, the condition of the structure, what repairs have been done, what it's used for, all those things, the geographical area, and give you a set number of years of performance warranty that we can say, hey, there won't be any further deterioration, or there won't be any elevation in chloride levels, or the permeability will be maintained, whatever's the most relevant there, and put a performance warranty. So that can be anything from 10 years to, if it's on a new structure, right up to matching the design life of the structure. So, and I guess another thing in that context there is structures. We literally put our hands up and say, hey, we're not going to provide benefit to you here. Either the structure's too far gone, and hey, it's most likely going to be demolished in a few years anyway, or there might be some other reason. We're prepared to walk away if it's not something that we can actually help on.
Yeah, excellent. Thanks, Doug. Did you have some project examples you'd like to share with us too?
Yeah, sure. Yeah, I think there's a couple we prepared earlier here. So the first one there is the Ohope Wharf up in Waikato. This is a recreational wharf structure, so used for recreational fishing boats, that type of thing, as well as it's a very popular swimming spot for locals and tourists alike. And it had some repairs completed about 10, 15 years ago. And these had started to degrade again. It's what's called incipient anode formation. It's basically where you've got old concrete, new concrete, and you get different electrical charges within that concrete, and it speeds up the corrosion process and causes further breakouts, often right beside the original repair area. So in short, they re-repaired the wharf, and we've sprayed out certain portions of that wharf to protect that effect from happening again, and with that provided a performance warranty that there's no further damage for, I think it was 25 years on that one. I just can't remember from the top of my head, but yeah, that's a good example there. I think the next one there is the Geraldton Wharf. That's over in WA, and where the port had recognised it as a at-risk structure from in terms of service life. There was some repairs that needed to be carried out on the structure, and they wanted to keep it in that same condition. So we got involved with the engineering, with an engineering firm as well, and they put a permeability reduction requirement on it. So they actually tested every work section down the wharf. So we ended up with a lot of data off that project. And on average, I think our lowest result you can see there was 75%, but it was closer to 80% average reduction in permeability. So that was, along with obviously our performance warranties, another cross check to give assurance that the product was doing what we said. So yeah, that's a couple there.
That's really interesting. Thanks very much, Doug. It looks like we've got a few questions to go over, so I'll start with this one here. If I only need one part of the structure treated, will it show up against the untreated parts?
Yeah, it's a good question. It comes up a lot. So often there's only one, element or one couple of cracks on a structure that the rest of the structure appears to be in good condition. It is possible just to treat those areas, but what we do need to bear in mind is that that could be either the start of that damage manifesting itself in other areas. So it's it makes sense to keep the set a benchmark that the structure's all protected at that one time. The other thing is often it's we're there, or the contractor's there set up with all the access, and it's not a lot more cost to treat the rest of that element or the rest of that structure while we're there, and you get that whole structure in that one condition. So yeah, that's helpful.
Nice. The next one is, what testing method would you recommend to determine the depth of chloride ingress into concrete?
We mainly work with either coring or drilling into the concrete, taking dust samples and measuring the chloride that way. There's a couple of different ways, either waterborne or the acid method. I just can't remember the exact name of it, to determine the chloride levels in the concrete. And we generally take them at either 10 or 15 mil increments down to the depth of steel. And that gives you a good picture of, one, how far the chlorides are in, and secondly, what levels they are at the steel, which is really the high risk area. And I've seen that next question there, whether the Rio itself has actually initiated. So there is a recognised percentage of chloride in the concrete. I think it's 0.05% of chloride as a percentage of the concrete, and that's a recognised level where it changes from corrosion initiating to actually propagating, actually forming an expansive rust around the steel and starting to cause damage. So generally, if you're in that below that 0.05%, there's it's not high risk, but you can start to pick up a trend of where it's heading. Obviously, as I mentioned, right at the earlier you can treat a structure, the better. Even if it's got no chloride ingress, it's still wise to protect it, because it is going to be subject to it at some point.
Now, the next one is regarding the spray on application. How soon after the application can the concrete be exposed to water? And it's referring to the splash zone within tidal waterway.
Yeah, that's a great question. Thanks. So it is a major benefit with these colloidal hydrogel treatments. In short, once they penetrate into the concrete and the gel's formed, so that's basically once the surfaces or gel starts forming, I should say, once the surfaces touch dry, you can apply water, or the tide can come back up again, and there's not going to adversely affect the product. So we often work in on jetties and wharf structures where we can only access at low tide, and we've got a few hours window to clean and spray the wharf, and then that tide can come back up again, and it doesn't affect the efficacy of the product. So that is a massive benefit. So some of the other treatments out there do have like a set drying time where it has to be dry. And that's not only just before, it's actually for a few hours after the application as well. Whereas this is it can actually be applied to damp concrete, and then as soon as it's penetrated in and it's touch dry on the surface, it's not affected by that salt water coming back up again. So yeah, that's No, I don't think that's good. Thanks for those questions. And my contact details are there in the chat there. So yeah, feel free if there's any questions to contact me there, or our website's got some very handy resources on it as well, and along with the contact form. So that's feel free to go there. And other than that, no, it's been good.
Excellent. That wraps us up for today. Thanks everyone for coming on board. We're going to be sending out an email with Doug's contact details, and also a link where you can request the recording. So have a great day, and don't miss out on our next session. Cheers.